Now we are in a new series called Normalization, and in the first video, you can see the link in description. We have explored the first informal design guideline that we use for relational schema designs, and now we are going to the guideline 2. The guideline 2 is eliminating anomalies, insertion, deletion, modification anomalies. So let's just dive right in. Guideline 2, that's related to eliminating insertion, deletion, and modification anomalies. Okay, so first of all, let's write down the guideline. Guideline 2. So what is it? Eliminating insertion, deletion, and modification anomalies. Deletion and modification anomalies. Well, the guideline 2 is self-explanatory. Anomalies are created when we have a poor schema design or if we have redundant data. Okay, so if we have these two, there will be anomalies whenever we are inserting, deleting, or updating the data. So as we use normal we have a structure to study these guidelines. So let's start with the principle or the definition. Okay, so the design must be uh, formed, or the design must be in a way such that it eliminates anomalies. Okay, so this one we should keep in mind whenever we are creating relations or when we are breaking down relations into smaller relations. Okay, and we know the reasons for anomalies. Reasons for anomalies are poor relational schema. Poor relational schema and well, redundant data. These are the reason for anomalies to rise. All right. So, what are our expectations here? What are our expectations here? Well, obviously, we have to eliminate anomalies. That's our expectation. And also, we have to avoid data redundancy so that we can save some storage space. Okay. So, the expectations, the first one is minimizing storage space, minimizing storage space by reducing data redundancy. Reducing data redundancy, which will ultimately help us to uh, actually eliminate anomalies. Okay, so we'll avoid anomalies. This is what we expect to do with the guideline 2. So guideline 1 was related to the logical concept that is stored in a relation. Okay, that was about attributes and relations. But this is about redundancy. This is mostly about tuples. Okay, so even though this is about tuples, we can always manipulate tuples by changing the relation or by changing the relation attributes that we already know. So before we go deep into this, I will just explain what are these anomalies. First of all, we'll talk about modification anomaly. Okay, modification anomaly. Okay, anomaly definition. Okay, this occurs when you try to update the data in the uh, database. Okay, if you make a change in a relation, okay, if you make a change in relation, that might require many changes. Okay, This occurs when a change in relation when a change in relation requires multiple changes. Requires multiple changes. For example, if you have department ID and department name in the employee relation, normally in employee relation, there is emp ID, okay, emp ID, name, and we will have department ID. Yeah, we will have department ID. If you also have department name, okay, in the same relation, if you have to change the name of the department ID, I mean department name for the specific ID, let's say there is 1, 2, 1, 1, 2, 1, 1, 1, 2, and if you have the department name as this is comma separated file, let's say, okay, comma separated file, so one CSV, so one and department name was IT, and they are changing from IT to, so here everywhere it will be IT, okay, here everywhere it will be IT. And let's say if you have to change from IT to public relations department, they are changing the name of the department from IT to information technology department to, they are changing to public relations PR, then you have to change this in multiple places. This change should be made in multiple places. Well, this is what we call modification anomaly. What's the problem here? The problem here is self-explanatory. Why? If you forget to change one place, in one tuple, well, what happens? There will be data inconsistency. Okay. The problem is if we miss to change in one place, there will be data inconsistency, and data inconsistency will reduce the quality of data. So that's very important that we don't have modification anomalies in our relations. Okay, there will be data inconsistency. That's the issue. Okay, that's the issue. And then we have insertion anomaly. Insertion anomaly is happen. This occurs when you can't add new data. If you have, if you don't have complete data. Okay, let's say if you have partial data, like you have just included an employee and you have not assigned a department for them, well, then you can't input that data into a relation. Why? Well, you have to have a department ID and department name in that bad schema design that we were talking about just a few minutes ago. So we have to keep in mind that whenever we are creating relations, this anomaly should also not be there. So this occurs when inability to input partial data. Okay, inability to input partial data leads to prevention of adding new data. Well, the problem is we can't add new data. Well, I can't say what the problem is. Well, we can't add new data. Add new data if the data is partial. Okay, if the data is partial. And then we have finally deletion. And this occurs when you delete some data that leads to non-intentional, unintentional data loss. Occurs when deletion of data leads to unintentional data loss. Related data loss. Related data loss. So what will be the problem? Well, our original data will be gone in A. Okay. So if you delete an employee from the employee relation. Okay, and what happens is when you delete this employee name, the department will also go off. So if you have one, let's say there is only one employee in the current department. Okay, let's say in the IT department there is only one person. That's the most cases in companies. So if that employee leaves the department, and if you delete that record, well, you can say bye bye to IT department actually in the relation itself. But in the company, there will be a IT department, and there will be vacancy. But in relation, we will be having no department, no such department. So that's why you should keep in mind that we don't make this mistake. Okay. So this is why we follow the second guideline, which helps us to eliminate insertion, deletion, and modification anomalies. Okay. So now you might have a doubt. Well, well, how can we do this without any anomalies? Well, the answer is decomposition, and that we will see in the next video.
Thank you for joining this deep dive into Informal Design Guideline 2 for Relational Schema. If this video helped clarify concepts, give it a like and share it with your friends who might also benefit. Don't forget to subscribe and hit the notification bell for more insightful lessons in this series. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.